In September of 2024, a hurricane's remnants dropped more than 2 feet of rain on a mountain city sitting nearly 2,000 feet above sea level, hundreds of miles from the nearest coastline. Asheville, North Carolina, had spent years being quietly marketed as one of America's climate refugees, a place too far inland for hurricanes, too high in elevation, for coastal flooding, too temperate for the extreme heat baking the rest of the country. Then Hurricane Helene arrived, and an entire regional economy built partly around the idea of climate safety watched entire neighborhoods wash away. That's the story playing out across America right now, in city after city that spent decades being considered exempt from the worst of extreme weather. The safe zones are shrinking, and the places replacing them on the danger list are the ones nobody prepared for. Let's be precise before this story runs ahead of the facts, because that precision is exactly what makes it worth taking seriously. This isn't a claim that nowhere in America is safe anymore. What we're going to walk through is a real documented pattern, specific places once considered havens now facing disasters they were never built for, and why the label safe zone is becoming far less reliable than it used to be. Start with Asheville because it's the clearest, most recent example of this pattern breaking wide open. For years, climate researchers and real estate analysts had flagged Asheville as a potential climate haven, a city insulated by elevation and distance from the coastal. Flooding and hurricane risk threatening much of the southeast. That reputation attracted new residents specifically seeking refuge from climate risk elsewhere. Now understand what actually happened in September of 2024. Hurricane Helene made landfall on the Gulf Coast of Florida, then tracked inland, weakening from a hurricane into a tropical storm as it moved north. By the time it reached western North Carolina, meteorologists expected a heavy rain event, serious but manageable. Instead, the storm interacted with the region's mountainous terrain in a way that dramatically intensified rainfall, dumping catastrophic totals across areas that had never experienced flooding at that scale in recorded history. Read that again, slowly. A storm that had already been downgraded from hurricane status still managed to produce one of the deadliest inland flooding disasters in modern American history, in a city that had been marketed as too far from the coast to worry about hurricanes at all. Entire communities along the French Broad River and its tributaries saw water levels rise faster than warning systems could adequately communicate, and some towns lost bridges, roads, and water treatment infrastructure that took months to even partially restore. The scale of destruction stunned emergency planners, specifically because mountainous inland terrain had never factored into regional disaster planning with anywhere near the seriousness given to coastal storm surge. Here's where it gets disturbing. Asheville isn't an isolated exception. It's part of a broader pattern researchers have been documenting across multiple regions simultaneously, each one previously considered relatively insulated from a specific category of extreme weather. Consider Vermont, another state long associated with a mild, temperate climate and relative safety from major weather disasters. In July of 2023, catastrophic flooding tore through the state after days of intense rainfall, damaging or destroying homes and infrastructure across communities that hadn't seen flooding at that scale since a historic 1927 flood, nearly a century earlier. Then, just over a year later, in 2024, the state was hit by serious flooding again, a repeat event that caught residents and officials off guard precisely because the previous disaster had been treated as a rare, once-in-a-generation occurrence. Towns like Montpelier and Ludlow, which sit in valleys that had rarely if ever seen water rise into their historic downtown districts, watched businesses that had operated for generations get inundated within hours, a level of destruction local officials openly admitted their emergency planning had never been built around. That's not a coincidence researchers are comfortable dismissing. It's part of a documented trend of extreme rainfall events, intensifying across the Northeast, a region historically associated with steady, predictable precipitation, rather than the sudden, catastrophic downpours now showing up with increasing frequency. Vermont's own state climatologists have noted that the intensity of individual rainfall events has been trending upward for years, even before the dramatic 2023 flooding made national headlines. That's an important distinction because it means that the disaster wasn't purely a freak, isolated event layered onto an otherwise stable climate. It was the most visible expression yet of a gradual shift that had already been building quietly in the background for years. But that's not even the most disturbing part of this broader pattern. Tornadoes, historically concentrated heavily in the traditional tornado alley, stretching through the Central Plains states, have shown a documented eastward shift in frequency over recent decades, according to research examining decades of storm data. States across the Mid-South and Southeast, including areas of Mississippi, Alabama, and Tennessee, not historically associated with the highest tornado risk in the country, have seen tornado activity increase even as some traditional tornado alley states have seen activity decline slightly by comparison. Let that land for a second. The very geography Americans have used for generations to understand where tornado risk actually concentrates is shifting beneath their feet. And emergency preparedness in some of these newly affected regions hasn't caught up to match it. Part of the danger in this specific shift comes down to something as simple as time of day and building type. Tornadoes in the traditional plain states often strike relatively open, flat terrain during daylight hours when warning systems and visibility work in a resident's favor. Tornadoes striking the Mid-South and Southeast more frequently occur overnight and hit denser tree cover and more mobile home communities. Combination researchers have specifically linked to higher fatality rates even when comparing storms of similar intensity. To understand why these shifts are happening across such different types of weather at once, hurricanes, flooding, and tornadoes, you have to understand the common thread connecting them. A warmer atmosphere holds more moisture, which means storms of all kinds have more fuel available to intensify rapidly and produce more extreme rainfall than historical patterns would predict. That single mechanism helps explain why storms that once would have weakened predictably as they moved inland or across cooler regions are now retaining more destructive potential further from their point of origin. Researchers studying Hurricane Helene's inland intensification specifically pointed to warmer Gulf of Mexico waters as a key factor, noting the storm absorbed unusually large amounts of moisture before making landfall, moisture that then got wrung out catastrophically once it collided with North Carolina's mountainous terrain. That's a mechanism that doesn't respect the old assumption that distance from the coast automatically meant reduced storm risk. Mountainous terrain, it turns out, can actually intensify rainfall rather than simply weakening a storm as it moves inland, a phenomenon meteorologists call orographic lift, where moist air is forced upward by rising elevation and wrings out its remaining moisture in concentrated torrential bursts. That's precisely the mechanism researchers point to when explaining why Asheville's elevation, once considered a protective feature, actually amplified the disaster rather than softening it. If you've made it this far, you're clearly someone who wants the real pattern behind these disasters instead of treating each one as an isolated, unconnected tragedy. That's exactly the kind of viewer this channel is built for, so go ahead and subscribe if you want more deep dives like this one. Now, let's be careful about what the research actually supports, because that precision protects you from bad information. Scientists aren't claiming every previously low-risk region is now equally dangerous as the highest-risk areas. What the data shows is a clear trend of extreme weather events reaching regions with lower historical baseline risk more frequently than before, which matters enormously precisely because those regions typically have less infrastructure, less public awareness, and less emergency planning built around those specific hazards. That distinction between increasingly at risk and as dangerous as the highest-risk regions matters for how you interpret this pattern. The danger isn't necessarily that Asheville will now face hurricanes as often as Miami, or that Vermont will flood as often as Louisiana. The danger is that these regions are facing disasters they have comparatively little institutional experience managing, which is precisely the gap that turned Helene and the Vermont floods into such deadly damaging events. Insurance markets have already started reflecting this shift in ways that affect ordinary homeowners directly. Some insurers have begun reassessing flood risk maps and premium structures in regions previously considered low risk, and residents in newly affected areas have in some cases discovered their existing coverage never accounted for the type of disaster that ultimately damaged their home, since standard homeowners policies frequently exclude flood damage entirely unless purchased as a separate, specific policy. So what does this mean for the broader idea of a climate haven? It means the concept itself needs serious reconsideration. A location's historical weather pattern is no longer a reliable guarantee of its future risk profile, and treating any single American region as fundamentally exempt from extreme weather is increasingly out of step with the data. So what can you actually do with this information? Start by researching your own region's actual current risk profile rather than relying on its historical reputation, since disaster risk assessments are increasingly incorporating updated climate projections rather than simply extrapolating from past decades. If you live in a region newly experiencing a category of extreme weather it historically hasn't faced, whether that's flooding, tornadoes, or extreme heat, take official warnings for that hazard seriously, even if it feels unfamiliar. Communities with less institutional experience responding to a specific hazard often see slower evacuation decisions and less effective emergency response, precisely because the warning signs haven't become second nature yet. Familiarize yourself with the specific warning terminology and evacuation guidance for whichever new hazard your region faces, since a flash flood warning, a tornado warning, and a hurricane warning each carry different specific actions residents are expected to take, and confusing them or hesitating to react can cost critical minutes during a fast-developing disaster. Advocate for updated infrastructure and building codes in your community that reflect current risk rather than decades-old assumptions. particularly around flood zones and stormwater management, since much of the damage in places like Asheville and Vermont stemmed from infrastructure that was never designed to handle rainfall at the volumes these storms actually delivered. It's also worth taking a practical look at your own insurance coverage, regardless of where you live. Ask specifically whether your policy covers flooding, since standard homeowners insurance frequently doesn't, and consider a separate flood policy if your region has seen any indication of the kind of shifting risk pattern this story describes, even if that risk still feels distant compared to your area's historical baseline. And here's the step people consistently underestimate. If you're considering relocating specifically to escape climate risk, research your destination's actual current and projected exposure across multiple hazard types, not just the single hazard you're trying to avoid, since the Asheville example shows clearly how a location's blind spot in one category can become catastrophic, precisely because it was overlooked. Before you go, let us know in the comments if your region has experienced a type of extreme weather it historically wasn't known before, because this pattern is showing up in more places than most people realize. And if you want to keep tracking how these shifting risk zones develop, stay subscribed, because we'll be following this story closely as new data comes in, region by region, season after season. Let's close where we started. A mountain city, nearly 2,000 feet above sea level, hundreds of miles from the coast, underwater from a storm that had already lost its hurricane status by the time it arrived. The safe zones aren't disappearing because the weather got worse everywhere equally. They're disappearing because it stopped staying where everyone expected it to. That's the shift worth carrying with you long after the story ends. The old maps, the ones built on decades of relatively stable regional weather patterns, are quietly becoming less reliable with every passing storm season, and the places still marketing themselves as exceptions may simply be the next ones waiting to find out otherwise.